Welcome back. We're going to continue this lesson with just one more type of example, and that's finding the second derivative for implicit functions, because things get a little bit more tricky here. We're going to do two examples, and that's all we'll do in this video. So I'm going to ask you to find d squared y over dx squared. Remember, that means the second derivative. And I'm going to be picky about this. I want this to be in terms of x and y. And I'll show you what that means when we get there. So the first one, we'll do something kind of straightforward. We're just going to stick with y squared equals 10x. Okay, the question asks us to find d squared y over dx squared. So first thing we'll find is the first derivative. Let's find the first derivative with respect to x, finding d over dx, y squared equals 10x. Okay, finding the derivative using the chain rule to y dy dx equals 10 dx dx. That right side simplifies to just 10. I can divide both sides by 2y. That means 10 divided by 2 will give me 5 over y. There's the first derivative. The question asks us to find the second derivative. So our next step then is to differentiate the derivative. Find the derivative of the derivative. Okay, first things first. Finding the derivative of dy dx, remember the d and the d, that's d squared y over dx squared. This right-hand side, the 5 over y, we get to use the quotient rule. With the quotient rule, I'm going to find the derivative of the numerator. The derivative of 5 is 0 times y without changing it, minus 5 times the derivative of y, dy dx. All over y squared. Okay, I'm going to simplify that and write it a little bit larger this time. 0 times y is 0, so we have negative 5 dy dx over y squared. We found the second derivative, but we didn't follow the directions in terms of x and y. Right now, we have a value in here that is not in terms of x and y. It's in terms of dy and dx. So we need to make a substitution. We need to get that dy dx out of there so that our derivative has only x's and y's in it, not dy or dx. Take a minute to think about how we could do that. Okay, the way we can do that is because we know that dy over dx is equal to 5 over y. So I can do a direct substitution. I can replace that dy over dx with 5 over y. So let's do that. D squared y, over dx squared equals negative 5 times 5 over y. There is no way in the world a multiple choice answer would ever leave this in this form. So let's do some simplifying. I'm going to multiply the numerators together. Negative 5 times 5 over y. And that gives me negative 25 over y. And this entire thing is over y squared. I can just combine these two denominators together, but I'll show you why. This is y squared over 1. If I flip it and multiply, now those y's come together in the denominator. So this y and those y's become y cubed in the denominator. So we end up with negative 25 over y cubed. Now we have our second derivative. It's only in terms of x and y. There are no differentials in there at all. So we're done. Okay, I'm going to give you one to try. This one's going to definitely be a little bit more tricky. So I encourage you to stop the video. I want you to try this. I want you to find d squared y over dx squared in terms of x and y. And here is the equation. X squared y squared minus 2x equals 3. This one's going to get a little ugly, but don't be afraid. Okay, pause. I want you to actually pause. Go give it a try and come back. Did you pause? Go try it. Okay, welcome back. Let's find the first derivative. I like using different colors. I hope you're okay with that. I'm going to find the first derivative with respect to x squared, y squared. I hope you were thinking about the product rule on that first term. So using the product rule, I'm going to find the derivative of x squared. So that's 2x dx over dx without changing the y squared, plus the x squared unchanged, times the derivative of y squared, 2y dy dx, minus the derivative of 2x, 2 dx dx, and the derivative of 3 is 0. Okay, let's do some simplifying. dx over dx is 1, so we end up with 2xy squared plus 2x squared y dy dx minus 2 equals 0. Our goal is to isolate the dy dx. We need to get the first derivative before we can find the second derivative. So I'm going to move this one and this one over to the other side to start isolating my dy dx. So we've got 2x squared y dy dx equals 2 minus 2xy squared. Okay, last but not least, I'm going to divide out the 2x squared y to the other side. So we have dy dx equals 2 minus 2xy squared over 2x squared y. Can you see anything else that will simplify? I hope so. I hope you can see that all of these can be divided by 2. So it's just going to make things a little bit more simple when it comes time to find the second derivative. Okay, this is going to get really fun because now we have a quotient rule. We're going to differentiate. We're going to find the second derivative of this first derivative. You ready? Let's do this. All right, the derivative of the first derivative is the second derivative, d squared y dx squared. Now comes the quotient rule. And within the quotient rule, we also have a product rule. So we're going to have to keep all of this in mind. Let's find the derivative of the numerator. It's not going to be short, I'll tell you. The derivative of 1, luckily, is just 0, so that's gone. The derivative now, I'm going to consider this to be negative x. The derivative of negative x is negative dx dx times y squared without changing it, plus negative x times the derivative of y squared, which is 2y dy dx. That is the derivative of the numerator only. We need to multiply that by the derivative of the denominator unchanged. Ooh, this one's ugly. Minus the numerator unchanged. I'm going to have to shrink this. Minus the derivative of the numerator. The numerator unchanged, sorry. Numerator unchanged, so 1 minus xy squared times the derivative of the denominator. Product rule again. Okay, the derivative of the denominator is 2x dx dx times y unchanged plus x squared times the derivative of y. All over the denominator squared. Oh my goodness. I'm going to do 2 changes or 2 simplifications at the same time, so I'm not writing too much. The first thing I'm going to do is simplify by making these dx's over dx's. I'm going to make those 1s and combine some things if I can. And at the same time, I'm going to substitute this in for all of my dy dx's. That way, this will all be written in terms of x and y only. Okay, so now that I told you what I'm going to do, I'm going to do it. So that becomes 1. That makes this first term negative y squared. And then this next term becomes negative 2xy. I'm going to replace the dy dx with 1 minus xy squared over x squared y. And then all of that still times x squared y without changing it. Oy. I'm going to shrink this a little because I didn't plan ahead. Oops, it's going to take the y with it. I'm going to shrink this a little bit. Oh, it took the y anyway. Darn it. I'll just write small. And that's lunch. So I'm going to finish this up. 1 minus xy squared times 2xy plus x squared. I'm going to replace the dy dx with 1 minus xy squared over x squared y. Oof. All over, oops, I forgot to square it up here, x squared y squared. Do you have to simplify this? No way. This would never be on a multiple choice question. All right, well done. Way to go.